Hello, this is Eric Evans with Surveyor Source, and today we're going to do a fairly short video on looking at some data from the DJI L1 LiDAR sensor, and we're going to bring the data into 3Dsurvey to do a little bit of processing. I think this project that we've got, I'm going to go ahead and open up the DJI Terra, is pretty typical, I think, of a project that the L1 would be well suited for. It's a project in a fairly open area, but it's got some areas of dense brush that trying to do this same project with a traditional photogrammetry was proving not to be possible. Too many details were getting missed. So we float with the L1, and I'll go ahead and bring in the LiDAR point cloud. I'll give this a mission. We'll call this College 1 because it's flown near a college. And we'll go ahead and point the software at the data containing the LiDAR information from the L1. This is directly from the SD card out of the unit, just like that. And it's noticed that one set of data has been identified. We'll go in some of the LiDAR settings. A lot of these we won't mess with too much, but some of these become pretty important depending on how you're using the sensor. We'll go ahead and leave the density as 100%. We'll use all the data in here. It's not a terribly big area. But under advanced, we'll look at a few options. One of them to pay attention to for a lot of projects is this point cloud effective distance. The L1 captures a lot of data, and from the sensor, it sweeps out. So the data, the further away it gets from the sensor, the less accurate that it is. So we can use this effective distance to limit how much data is actually going to be brought in for us to use. Now, typically, the sensor, from what we've been able to use it for, works really well at about 300 feet flight elevation. This is a project where we did 3 returns, so we got 3 returns, hoping to get through the vegetation with those 3 returns. Roughly somewhere about 320 feet is maybe a setting to think about from the sensor out. This project was done at 50% overlap, so I know about how much overlap I've got in between each of the flight patterns or the flight paths. Now, I'm not going to do that. I'm going to leave it at the default, which is just pretty much everything, because I'm trying to get under the trees and vegetation, and the accuracy required for this project, limiting the distance is really not going to matter. But this setting here can really increase the accuracy of the L1 data, because you can limit that unnecessary data that you're capturing that's not accurate and just focus in on the data that is the most accurate, which is pretty much the stuff that's right under the sensor. Next one here is the optimization of point cloud. So each path, you can think about it as a pass containing strips of point cloud data. Optimization actually will compare those passes, and if there's any differences between them, make small adjustments. So this is, again, something that can help with accuracy on the point cloud by optimizing each pass. So those are the 2 that I would really focus on. Again, I'm not going to do it. Oh, and by the way, these require the Pro version of Terra to even have these settings available. So I'm not going to leave them. I'm not going to mess with these here. I'm just going to take as much data as I possibly can, and we're going to clean it out later. This is a known coordinate system, so I'm going to set it for the coordinate system that I know that it is. I can apply a geoid here, which I probably should do. We'll do an AVD 88. So this would, all the data that comes in as an ellipsoid height, so this will correct it for sea level or orthometric height. LAS is a common output, which is going to work well with our 3Dsurvey software, so it's going to select for the output. And this is pretty much it in terms of getting through the first part of it, creating some data that we can bring into 3Dsurvey. So let's go ahead and start processing. All right, and the next message we're going to get is reconstruction complete. One of the advantages of using LiDAR over photogrammetry is the processing time. To get to the point that we're at only took about 2.5, 3 minutes or so. And again, this wasn't a big area, but compared to doing this photogrammetry, it would take quite a bit longer. And there's our data. You can kind of see some of the strips if you look at the point cloud. So that's the strips of what's flying over each pass going north and south like this. And again, we flew this at 300 feet. Seems to be a good height for the L1, at least doing the 3 returns, which again, 3 returns would give us a better chance of getting in this vegetation. You can kind of see that a lot of this is open, but we've got these fairly large trees in here. And there's actually a flow line of interest that needed to be captured. Again, traditional photogrammetry would not get that. But they also even tried to take RTK GPS and could not get a satisfactory enough signal in these areas to be able to capture this information. So looking at the L1 for something like this, I think this is probably a pretty common use sample for something like the L1, where it's good thick vegetation, but not extremely so, where the L1 with the 3 returns has got a good chance of getting through it. Now, at this point, I can leave Terra. The LAS has been created, and right now I'm only really just looking at the data here. If I want to kind of QA/QC it maybe, or look at it in some sort of detail. But really, I want to get to 3Dsurvey. We're going to actually start producing deliverables. Now, 3Dsurvey, if you click on New Project, normally it'll just prompt you to load some photos. But don't have any photos with this. This was done with LiDAR. So what we're going to do is the point cloud pull down up here. We're just going to hit load. And where DJI puts this LAS file is kind of interesting, I think. In your documents, when you install Terra, you get a DJI folder there. If you go into Terra, it's by username, so this is me. And if I go look into that folder that's automatically created when I created that little mission there, if I look in LiDARs, plural, under LAS, which is what I created, there's my data. It's just named with a default name. So we'll click on that, open it up, and this shouldn't take very long. Again, there's no processing as there would be with photogrammetry with this LiDAR data. Bringing it in Terra, that 2.5 minutes. And again, we didn't have any optimization on, so it was pretty fast. The processing differences are pretty extreme between the photogrammetry and L1, or LiDAR data in general being just much faster. So I've already got to the point where I've got a point cloud. 3Dsurvey is primarily a photogrammetry tool, but it's got a lot of great tools for just using LiDAR data in general. And in fact, any of the things that you do with the photogrammetry-based point clouds in 3Dsurvey, we can also use the same tools for bringing in LiDAR data. There's one specifically that I am going to focus on. Now, my general preference is to have a cloud that's the raw cloud. So anything that I do can always go back to the raw cloud if I do something wrong, if I delete data accidentally, which is actually pretty tough to do in 3Dsurvey. But I still like to do this by out of habit. Let's call one raw. I usually just call the other something like working, and I'll turn off the one that I'm not using. Again, it's just a duplicate. This is more area than was needed. The project is really just in this middle area. So I can just right out the bat start getting rid of just unnecessary information by drawing a polygon around it. All right, now that I've got the area that I want selected, we'll go ahead and delete other. So we'll just delete anything outside of my selected area. So I can just focus in on the project or the data that I really want. If you've seen other 3Dsurvey videos, and this will be very familiar, one of the tools here is classification. Classification just identifies particularly the ground. That's what 3Dsurvey software focuses on, identifying ground and getting rid of everything else. Now, there's a little button here that's going to be critical because this is, again, LiDAR data. So this point cloud from laser scanning is going to adjust our settings, knowing that this is coming from a laser scanner. We'll hit next. After a quick calculation. So it's essentially looking for here is lowest point. And if I select an area, if you look at the top here, it says classification. First step is to select an area that represents the ground. So right out here, it's pretty much ground stuff that we want. Anything that's not in red, or not with this red shading, will be things that are not on the ground. That looks pretty good. Now if I hit next, it does give me the option to anything that wasn't in the original selection. I can select it here in case an area that was walled or fenced off wasn't included in the classification. So in this case, we're fine. We'll hit finish. All right. Now that I've got my area selected that I want to be classified, we're going to go ahead and hit delete other. And it got rid of anything that wasn't classified as ground. We've got some holes here in the data where we have no data, but for the most part, we're probably going to get everything we need out of this. The next step is I'd like to go ahead and mesh it, because ultimately I need to get this out as a surface file. It's typically what we're using 3Dsurvey for, is produce surface files and bring it into CAD and then do all our normal CAD work there. So go to your mesh and calculate your top-down DSM. And I just want ground. I also don't need, because I got rid of it. Cell size is the size of the triangles that I'm going to create. This is only needs to be a 1 foot, so that's totally fine. In fact, I could probably go something looser than that, still be okay. We'll obviously fill the holes here with the mesh, because we do have some holes, and we'll calculate that out. Shouldn't take very long. All right, now that I got a mesh selected, it doesn't look like much, but again, some other tools included in 3Dsurvey, and one of these is really useful where you've got this sort of area where you need to see detail. Just show it on a height map. Now we've already reviewed the area, and some of the interesting features that we needed to show were picked up by the L1. Again, this is that flow line that we were talking about that was under those trees. You can see the detail here is pretty good. Again, we couldn't get there with a survey grade GPS. To do this with a total station or something like that would have taken a very long time. We flew this area in about 12 minutes, so it didn't take very long at all to fly. And since it's not photogrammetry, the processing was very fast. But some of the other details that were pointed out to me were some of these berm features that they knew were there. So working with the surveyor and showing them some of these details, these things really stood out as things that they recognized were in the field that they were expecting to see in the data set, and then they showed up here very well. So really happy with the L1 in this particular project. It captured data that was tough to get by other means and gave us a data set within the accuracy of the project requirements. So it all fit together. And again, I think this is fairly typical of a project that a surveyor might run into in the field where the conditions are challenging, and something like the L1 would be a huge benefit. At this point, we can save our mesh out. We can create CAD points. We've got all sorts of options here, same as any sort of 3D survey project I would do with photogrammetry. You've got the same outputs with the LiDAR data, except of course the orthophoto, because this was captured with the laser scanner. We'll quit that here. For any other questions, feel free to leave comments or contact us by visiting our website at www.surveyorsource.com.